This is the first of several podcasts on calculations involving gases. This first one is looking at the relationship between pressure and volume. As a gas sample is compressed, you will notice that the particles don't change in number, but since they have less space to move around in, they will strike the walls of the container more often, and as such, we state that pressure is inversely proportional to volume. That is, if the volume goes down, the pressure goes in the opposite or inverse way, meaning it goes up. Let's look at a problem. If you have 2 liters of gas at a pressure of 1 atmosphere, and then you change the volume, and the new pressure is now a half an atmosphere, what's the new volume of the gas? So here's sort of pictorially of what happens. The 1 atmosphere pressure becomes a half an atmosphere. You notice the number of particles, again, hasn't changed, but now, since the volume is larger, the number of collisions with the walls of the containers will be less. So, the solution is you write down all of your knowns, the unknown being V2. V1 and P1 indicate before anything happened, V2, P2 indicate after it happened. Then the calculation line is you take the volume you're given. Now, since you know that the pressure is going to go down, that means the volume must go up. So you make the fraction such that you have the larger number on top and the smaller number on the bottom, and we get the correct value of 4 liters. What we're saying is that because P and V are inversely proportional, and the P went down, so the V has to go up, and so we use what we call a top-heavy fraction in the calculation. And then the final value, being larger than the original, makes sense to us. Now this happens to be Boyle's law. Okay, Boyle's law states that pressure is inversely proportional to volume, and it just simply means what we've already said. Okay, and this is named after Robert Boyle, who was the son of the Earl of Cork in Ireland, who did a lot of experimentation.